Okay, so without further ado, I'm going to call on Maitri Fischer, who is one of the founders of Eco Mantra and has been doing an incredible job in really integrating sustainable thinking and sustainable design into some really amazing hospitality projects in Bali and beyond, I think, to really give us an overview of the industry and what the opportunities are in Indonesia. Thanks, Maitri.
Thank you, Jennifer. So I have a presentation which will guide our conversation, but I'll introduce myself while we get that on the screen. So hello, my name is Maitri. I'm a Bali kid. I grew up here since '89. I moved here when I was 1 year old. I'm a geoscientist, astrophysicist, came back after my master's degree to start Eco Mantra with my business partner. Our primary goal is to help developers find a way to develop in Indonesia and Bali around the world with a lower environmental impact. How can we ultimately develop in a way that is in harmony with the environment, taking advantage of the environment for our buildings, and doing so responsibly? Okay. Oh yeah, great, cool. Jennifer has asked me to provide an introduction to the topic of decarbonizing the construction industry. So I am trying to do that quickly today in 15 minutes. It's a much more complex topic, but I will give it a go. So our company, Eco Mantra, we empower leaders, operators, and developers in the transition to a sustainable future. Primarily, we work with hospitality, but we also work with schools, we also work with factories, we also work with residential projects, we also work with larger developers and master plan scale work, malls, factories, the entire plethora of the construction industry, of buildings, of, yeah. Okay, so in my opinion, and perhaps many other people, anthropogenic induced climate change is the most challenging and most urgent global issue that humanity faces today. If we are to try and avoid catastrophic damage to our ecosystem, loss of biodiversity, food systems, collapse of environments, issues triggered by mass migration, we need to maintain a climate that is at most 1.5 degrees Celsius warmer than pre-industrial levels. In the last 800,000 years, you can see in this graph over here, similar graph that was presented before, we haven't exceeded the carbon dioxide concentrations seen in the atmosphere. And since records began in the pre-industrial levels, these are actually measurements, we can see a very thorough correlation between carbon dioxide and the increase in temperature. There is no doubt that anthropogenic increase in CO2 concentrations in the atmosphere is the primary cause for climate change. Now, since we're here to talk about the building sector and industry, globally, 39% of greenhouse gas emissions come from buildings. There are two parts, generally, to a building. Its construction and eventually its operation. Now, there's also the demolition, but primarily we're talking about the construction and the operation of a building. When talking about construction and operation, we have about 11% of our emissions that come from the embodied carbon. That means the carbon inside a building, in the materials, in the bones, in the furniture, in the appliances. 11% of global greenhouse gas emissions come from that. 28% of global emissions come from operating the building. So one might think that it's more important to focus in how we operate a building, but actually we also have to focus in the building materials. And I'll explain a bit more in detail why later. Scientists and research is basically indicating that if we want to hit our 1.5 degrees Celsius warming target for planet Earth and avoid catastrophic damages, then the general agreed target as per IPCC and World Green Building Council is that by 2030 we should strive towards all buildings having 40% less embodied carbon. So today I've primarily put aside to talking about that, how we can reduce the embodied carbon in buildings by at least 40–50%, and also by 2030 that all buildings must operationally be net zero carbon, meaning that our energy required to operate buildings should also be decarbonized, and that by 2050 all buildings should have no carbon footprint associated with their construction or embodied energy, and no carbon footprint associated with their operations. So this is what the world, what scientists, what people in our industry are moving towards. And this is what, if we have products and solutions, we should be developing to support. Now, if we can do it before that, even better. Okay, so this is where we talk about life cycle assessments, and most people fall asleep, but I will try not to get into too much detail. The life cycle of a building is defined by, well, from over there till over here, where you have the production of the products used to build the building. You have in red. In orange, you have the construction of the buildings. Then you have in green the operations and maintenance of the building. In blue, you have the end of life. And in dark blue, you have beyond the life cycle, so recycling, upcycling, and downcycling. What's interesting, and the reason why we have to focus on embodied carbon and not just operation carbon, is actually because in the next 30 years or so, although the embodied carbon in building materials represents 28% of the building sector emissions, we expect them to account for about half of the overall carbon footprint in the construction industry between now and 2050. So they are as important. Between now and 2050, when we have to achieve our goals, the issue of embodied carbon and operational carbon are equally important. We are today talking about the part of a building life cycle that is in that red box. This accounts for 80% of a building's emissions in its construction pre-operation phase. Approximately 80% of embodied carbon comes from the structural materials required to hold a building up. Steel, as we see here, the predominant choice of structural material, sometimes concrete, sometimes wood, and so they account for about 80% of the building's embodied carbon. So if we were to use the 80-20 principle, so to say, we don't so much have to focus on, say, a table. More we should focus on the bones and the building blocks that make a building. So the elephant in the room, how do we substitute conventional concrete and steel with low embodied carbon materials? In Indonesia, this is quite challenging. We do assist our clients and provide embodied carbon calculations to erect new buildings. And the biggest challenge that we face in helping our clients build low carbon is access to materials on our Indonesian market that are low carbon materials. We do not have access to recycled steel. We do not have access to concrete, which relies primarily on recrushed aggregates or recycled aggregates. We have a hard time finding contractors who are willing to talk about adding fiber reinforcement into cement slabs to decrease the concentration of structural steel. The industry in Indonesia and most of Southeast Asia, for sure, is at its infancy. So if you are developing solutions and products that allow us to decarbonize the construction sector, now is the great time, because now companies like us need to be able to use those materials in helping our clients build. Block Solutions is a fantastic example, which we'll talk later, and so is Cull Timber, in providing alternatives to structural, somewhat load-bearing materials that can replace high embodied carbon materials. We don't have to reinvent the wheel. We have the standard LCA process, which has well-developed documentation for how to decarbonize the sector, how to do the calculations, how to prove it. And in Indonesia, you can certify buildings or projects through the Green Building Council Indonesia, or through EDGE, which is an IFC mechanism. So World Bank Group and Greenship is part of the World Green Building Council. Primarily, focus in embodied carbon in buildings is just starting. So in EDGE, which is a locally available certification for buildings and for operating buildings, you already have a low carbon certification. For Greenship, it's primarily focused in operations, but within the next 2 years, they will release the guidelines, which will concern embodied carbon. The reason why I bring this up is because we're all striving to achieve an end goal, and structures, certifications, institutions exist to provide the guidelines and the structures for us to follow so that what we do actually works. There is a lot of pseudo-claims, pseudo-science in sustainability, so let me just ask that we all follow guidelines and principles that are agreed and certified and set out by international bodies. It's very important. We can go about and make our own claims, but if they don't fit into a certified framework, it can also cause more harm by misleading clients or consumers. So I mentioned before that we work with our clients to try and do this, and I will show you an example so that you believe me that it's possible in Indonesia, albeit difficult. Typically, when we do an embodied carbon calculation for a project, you need to start with a baseline. So what is the building case for business as usual, right? And then we will develop a new building with our client that is going to be 40, 50, 60% lower embodied carbon than that building. So here's an example for a small modular residential project. It's an actual project in Bali. Cull Timber was involved in some of this. This is a standard Indonesian construction of a house. We have steel framing for our roof. We have tile roofs, clay tiles. We have a stone concrete foundation. We have batako or bata walls, and we have reinforced concrete structural columns, H-beams, horizontal and vertical beams. You can see that the carbon footprint associated with a building, I believe this building is 8 by 8 meters. It comes down to about 48 tons of CO2. And the calculation is much more complex than this, but I'm not going to go into that. What we need to understand is generally buildings, conventional buildings, we're looking at a carbon footprint of somewhere between 600 to 800 kilograms of CO2 per square meter. So our goal, your goal, is to cut that in half by 2030. How do we go from 750 kilograms of CO2 per square meter for a building down to 375? This is an example of a prefabricated cabin, 8 by 8 residential ready, and using locally available materials, we have reduced the carbon footprint of this building by, I think, about 60%. Replacing conventional materials with recycled timber, which has a lower carbon footprint, about 90% lower than conventional timber and concrete. Using wooden and low carbon roofing materials. Using screw foundations rather than river stone and concrete footings. using wooden panels and insulation in the panels to create mass and a low-carbon panel. Now, in Indonesia, we're almost forced to go towards timber as a solution to decarbonize buildings because we just don't have access to other materials. I hope Block Solutions will come through with a fantastic replacement here. Okay, so yes, it's possible in Indonesia. This particular project, okay, it's 52% reduction in its embodied carbon compared to a baseline model. So I think what's important to say is that we look forward to solutions besides timber, because as we go into bigger buildings, we need access to cross-laminated timber, engineered timbers. We need access to recycled steel. We need access to recycled aggregates for concrete. We need access to carbon-negative materials like additives that are added to concrete that pull out CO2 from the atmosphere as it cures. There are all these solutions that exist in the West that just need to be brought here and combined with a lot of your great ideas. Okay, the other thing I'll add, just as a caveat, climate change is not the only environmental issue that we have, and one problem that we do face is what we call carbon tunnel vision, where we all look at, okay, carbon emission and climate, but actually the impacts of global climate change, population growth, urbanization, movement towards deltas and cities is causing all kinds of other issues that will amplify the challenges that we face as a humanity to live on Earth. So please don't lose sight of the other environmental issues as well. That's just something I'd like to say. Okay, thank you. This is just some of our team, and I will leave this on the board for you guys to read. Okay.